Earlier on, we described kinetic friction, and when I introduced kinetic friction, I also introduced this idea of another frictional force that was between two objects acting before one is moving against the other, basically resisting the start of motion, even when there's a pushing force applied. That force is called static friction. Again, static friction is the frictional force between two surfaces that are not moving along each other. Static friction keeps objects from moving when a force is first applied. You can see that from our diagram over here. And again, just as before, what we essentially have is the roughness of the two surfaces interacting with each other and basically just kind of locking at that point just before enough force is applied to break it loose and allow it to start moving. Now let's take a look at the formula for the static frictional force. It has a form that is very, very similar to that for the kinetic frictional force. Here we have frictional force is less than or equal to the coefficient of static friction times the normal force. The structure is basically the same. A coefficient of friction and the normal force are related to the frictional force. However, here, what we'll notice is that there's an inequality. We'll talk about that in a moment. One thing to note is that the coefficient of static friction, just like that for kinetic friction, is different for every pair of surfaces. The important thing about this equation is the less than or equal to symbol. What's important here is that the force of static friction is always equal to the applied force on the object. So the more the applied force, the greater the force of friction. In other words, it matches the applied force, keeping the object from moving. So imagine you're pushing on a box until it moves. You can apply a small force, nothing happens. You keep applying more and more force, and as you apply more and more force, the frictional force again is exactly equal and opposite until you hit a point where you apply enough force that the box finally starts to move. That's the maximum amount of static friction. That is what the coefficient of static friction times the normal force represents. So friction can be less than the maximum amount or equal to the maximum amount, but never greater. The force of friction is equal to the coefficient of static friction times the normal force at the instant it starts to move. But then what happens? To get a better understanding of how the static frictional force works, let's have a look at the graph that's displayed here on the right. What we note is that as the applied force increases, the frictional force also increases. In fact, it's exactly equal and opposite to the applied force. Because it's countering the applied force, the object that's being pushed or pulled is unable to move. So as the applied force increases, so does the frictional force until we reach this maximum, where the frictional force is equal to the coefficient of static friction times the normal force. When you get to that point, that maximum, the object begins to move. And suddenly, we move from static situation to a kinetic situation, and the coefficient of friction becomes the kinetic coefficient of friction. And the frictional force becomes a constant. It no longer varies with the applied force. It just depends on the normal force. Again, the normal force just multiplied by the coefficient of kinetic friction. So at this point, the applied force can increase, but because the frictional force is fixed, the object is able to accelerate. Earlier on, we showed you a table of coefficients of kinetic friction. And here we want to present a similar table showing you the coefficients of kinetic friction alongside the coefficients of static friction. The patterns from material to material are pretty much the same as they were in the solely kinetic case. Certain materials have much lower coefficients of friction than others. But what's important to note here is that the coefficient of static friction, which we see here, is always somewhat greater than the coefficient of kinetic friction. Once the coefficient of static friction is overcome, once an object begins to move, you can see that it's easier to keep in motion because this coefficient is always less. The kinetic one is always less than the static one.